or anyone, even if you can notify me.
Okay, I'm not fair. Joanna. I think Jolene is not able to talk, so she's using the chat.
Okay, okay.
Yeah.
So I realize some people have a lot of issues in the statistics, and I want to go from the very, very basics so that everyone will understand statistics. I want to go from the very basics as we advance all the way to statistical, you know, distribution at the moment. So I want to begin with, the very basics. The first place I want us to understand this distribution. I'll use a module called random in NumPy so that we may discuss the distribution. And then once we get from there, once we understand different type of distribution, and then we shall talk about the hypothesis testing, and then we shall talk about these statistics in details. Actually, the statistics in details, yeah. So, and for me, I don't have like a I haven't prepared the slides, so you'll just excuse me, we shall be writing the notes as we go on, in case you need the notes. So let me just create a folder, perhaps I can call it something like, um, I can call it statistics, statistics, and let me just call it statistics. Do I have another folder called, there's also another folder. Let me call it statistics, something like two. Jupyter. And then guys, whenever you don't understand, you just ask questions. And as well, sometimes I can mention things which doesn't make sense. You can add in your input. Also, you can say anything, and I'll also be asking some questions. So help me make it more interactive. And by the way, we had the ALX. We have the ALX officials and also the delegates within us. I was to give them a chance to greet us, but I think because my time is limited, I think you'll allow me to give you an opportunity next time. The ALX delegates and the official within us. They're also in the study group. I think I'll give you another opportunity maybe in future, but today I want to maximize on my time very well. Sorry, you'll excuse me. So I can call this notebook anything. Stats. Or I should have called it distribution. Distribution. Guys, make sure you understand everything that we are going to discuss here today. Now, in NumPy, NumPy is a package for numeric. It deals with numerical computational numerical data. So for NumPy, we have another package within it called random. And I'll be using this random module because I'll be generating some random values so that we can understand how well it works. Remember, I told you that NumPy is very, very big. And in fact, the other time we didn't even touch the quarter part of it. So I'm going to talk about the random. Is just a small bit on NumPy, and we have other things also. We shall talk about it in future. But I want to talk about the random to discuss this distribution because I'll use the random distributions, a random data distribution, and then later, once you understand the basics, I'll talk about the hypothesis testing in brief, then I shall advance to the statistical distributions. So let me begin by asking you a question. What is a random number? Anyone? Now let's say in your you have a basket that contains the balls. I don't know if you guys have ever played those lottery things. Like for example, you are selecting, you have some balls there with numbers in it. You are like you are just choosing some random ball with a particular number. So let's say in that thing you have like let's say 10 balls with the numbers in each. So who can tell me in that context what is a random number within that context?
Hi guys. Hi Nema.
Hi, hi.
Yeah, I'm not okay today, but let me try. I think a random number is a number that can take any number within those 10 balls in that basket.
Yeah, yeah. So I think in other words you mean that it's something that cannot be predicted like logically, right?
Yeah, it's something like okay. I was avoiding to use the word a variable or statistic, but let me just use variable.
Mm.
It is a variable that can take any number, and you cannot say that that is number 10 or number 5 or number what. From my understanding.
I think that's also correct. So it essentially means that, for example, you have 10, or maybe let's put it in a clear way. Let's say that it means something that cannot be predicted logically. So, for example, you have those 10 numbers within a box. It doesn't mean like, for example, if this first time you selected one, and there's a probability you select a different other value. You can still select the same number. In fact, you can even select it like 10 times, selecting the same number, but it means that you can't like predict that number. That's just a random number. You just select anything out of the menu or out of the many things. You're just selecting, some random number. So basically, the random number does not mean a different number all the time. But in a nutshell, the random means something that cannot be predicted, logically. So we have a module that can help us generate the random numbers, and the module a numpy is random from a numpy. So first of all, before working with this one, ensure that first of all you have a numpy in your system. I think let me just create a heading here, and then I call it uh, let me call it how can I call it random data, because this is the topic that we are discussing, random data distribution. And then so within it, so basically you need to have you need to have numpy. So for example, assuming that you don't have it, the command to install is pip install numpy, and then I think let me zoom in. Are you able to see well, guys?
Yes, I'm able to see myself, but I'm wearing specs. I don't know if others are able to.
Another person can also confirm.
Yeah, we are able to see.
Okay, so I don't have to zoom in further. It's clear. Thank you.
Yes, yes.
So within this, remember NumPy is a package, and within that package we have other sub packages and modules. So like in this NumPy we have another module called random. So we can say from from NumPy import. From NumPy we import random. But there, guys, the same thing can also mean like for example import NumPy dot random, and you can use it as an alias. So for example, something like anything. Like for example rd, something like that. So these is the same thing. For example, this one, it means that you're importing random from NumPy. Whenever you have a dot, it means that you are sourcing it from the main package, which is numpy. So it's just the same thing. Like in most cases, for example, a good example is matplotlib. You will see in most cases they say import this is out of the topic, but I think you need also to know these things. So like in most cases you'll see that they say for import matplotlib.pyplot is plt. So it means that you're importing this pyplot from matplotlib, but you're using it as an alias. So the same statement could also mean from matplotlib import what pyplot. So it's just the same thing. So the preference is the choice is yours. So I'm using it this way. I'm importing the random module from the from the actually from the numpy. So let's try to generate here some random values. So basically basically the random only works with the random numbers, be it a floating number or the whole number. Floating number, these are the numbers, the real numbers. Floating numbers, these are the real numbers, the number with decimals. And then the integers, these are the whole numbers. So let me create a variable. Can I use which variable? Let me just use x and y. And then let me assign here to, first of all, you begin with the module name that you're using. So it is random. I could have used it as an alias, but I think in most cases they usually use it direct random. And then now within that random, there's a function called rand int, which will generate random integers. Integers, remember I told you these are what? These are whole numbers. Yeah, thank you. So for example, when I say, for example, generate these values, then it's going to generate like a one-dimensional array with random integers within the range of 100. So like between like a zero, if you don't specify, it will be like from 0 to 100. So let's do it. Let's generate these values by printing out the variables. So let me run, and then actually it's going to generate a random integer. So I didn't specify. So it's going to generate a random integers from a range of 0 and 100. So it means that it's not like going to surpass surpass 100, though you can specify the starting point, but if you do not specify, the default one is 0. So for example, if you could have specified like for example the starting point to be something like let's say 100 to let's say 1000, then the random number that will be generated will be within that range. So let me try to run it again. You can see it will generate a random number, but all the numbers here are within the range of the numbers are within the range of 100. So sorry guys, I'm going to talk about the distribution in a few, but I want you to understand how you generate the random numbers. So if you specify, for example, if you restrict it to 10, you will realize that the numbers will only fall in that range between 0 and that 10. So now, how about to create a float number? A float number you use now for integers. We used the rand int. But if you do not like, can I add in here a comment? Let me try to add in a comment, and then let me say random integer. Then this other one, let me say random float. Float is a real number now, the number with decimals. So we basically use the rand method. So let me again, should I have to repeat everything? Let me just copy these things, because I'm going to use this random to generate like our data, because I don't have like a data set here. I'll just use the random data generated to discuss the distribution. So I'm going to discuss it in a few, just bear with me, because I want to understand like how these things do work. So for rand, you don't have like to add in that int at the end, you just say rand, and then if you do not specify, it will generate like any random float from a range of 0 to 1 if you do not specify. So you can see it generates this random, but it can't surpass 1 if you do not specify. So but you can as well generate a random array. So this one it has just been returning a scalar, a single value. So let's try to generate, for example, an array. An array in number, you understand these are they are defined in dimensional levels. We have 0, we have 1, and so forth. So and again, I believe you understand the axis. So for 0 axis, it means that it doesn't have any dimension there, and then for 1, it has like one dimensional array, and then 2 axis, it means that it has two dimensional array. Let me show you that now. So for example, you want to like return a random. Let's begin with an integer, and then I shall try with the float. So you can specify, for example, that value the number that you want to be returned should be in the range of 0 to 100. Then you can specify the size. The size these are parameters that you can assign here. So you can, and I guess you realize that this one is an arbitrary keyword argument. Can someone try to explain if they understood the arbitrary keyword arguments? You can try to explain maybe. I see if you understood the functions. Any sharp student? So basically, arbitrary, you can see like in this when they were defining like this function inside the random, it was like the arbitrary keyword arguments in such a way that it takes any number of arguments. Like you can see there are some arguments when you add in, like for example, I'll show you just in a few. For example, those distribution that we are going to discuss, they are limited, for example, to the parameters that you can pass in. But for arbitrary keyword arguments, it means that you can add in as many as you want. I think I'll explain it well when we reach there. So in this case, we are going to generate here an array, a one-dimensional array, because we only have one axis here. One axis here, it means that it's one dimensional array. So it's going to be a list or an array containing what? Containing the values, containing 5 values, and the range should be between 0 and 100. So you can see the range is between 0 to 100. Now, if you do not specify, you can guess what will happen if you do not specify the first parameter. Anybody? If you are following, if you do not specify the range, like these values.
Come up again, Emma.
I'm
Okay, I
saying,
wanted to answer.
It may be
yes.
1 to 100 straight.
Pardon?
I think if you do not specify,
Yes.
because there's a function that you did up there,
Mm,
and you use the word, and you used rand without the
mm,
word int, but if you
mm,
use int,
mm,
and maybe you do not specify into the brackets, then
mm.
that number, I guess it will give you a maximum of 1 because it's an integer.
Yeah.
Actually, it will mean, I said earlier that the range will be between 0 and 1. So the number that will be returned should be within, let's try and see first of all if it will. Basically, it should work for floats, I think you should work on floats. So if you do not specify, it will return like numbers between 0 and 1. 0 and 1 if you do not specify. But on the integers, you have to specify, because any number between 0 to 1, that one is automatically what? A float. So if you do not specify, then basically you can see rounding takes at least one positional argument, and it was given 0. So it only works on the float, but I should have changed here to float so that I can ask you that question. But so the first one, this one defines like the number or the range that the values are going to be returned, like the maximum number that is going to be returned. That's why when I run it again, it will generate another random number, but the range should not surpass 100, between 0 and 100. Anytime I run it again, you see it will generate a different number. So this is round int. And we also have the same with the same should also work with the round what? Round for float. Float is here I should have changed here to float. Sorry guys. You could have told me random one D what? 1D array. Did I did something else there also? Yeah, I think it's clear now. So for a float number, that one you don't have like to specify. The values will be, let's first of all check. So for float, these are the real number. You don't have to specify to make it an int or what. So you can say, for example, something like, let's say something like a 10. It will mean that it's going to return an array between 0 and 1, but the number of elements that is going to be returned in that one-dimensional array is what? Is 10. So when you count, this number will be 10, but because we didn't specify the range, it's going to be defaulted between 0 and 1. Also for a two-dimensional array, you can just specify. Now for two-dimensional array, anyone who can guess the axis, the number of axes that it should have? A two-dimensional array. How many axes?
Let me try. I think 2.
Yeah, that's true.
X and Y.
Yeah. That's true. That's the rows and columns So for example, you want to like return what? You want to return a random number in a two-dimensional array, and then the rows are going to be, remember the first axis always represent what? Represent the rows, and then the columns are the second axis. So the second axis is going to contain five what? Or let me use something like a 4. Is going to contain 4 like values. Like each element is going to contain 4 values, or a 4 columns, if I can say that. I don't know if you are understanding. So whenever you use, now for example, if it were a 3-dimensional array, you could have 3, where the first argument, the first axis defines the number of blocks, because on a 3-dimensional arrays it contains two-dimensional array as its element. I don't know if you are understanding. It contains two-dimensional array as its element, so you can have several two-dimensional arrays. So the first one, will say, for example, 1, it will mean that the first axis is going to contain like the first block of the two-dimensional array. If it were 2, it's going to mean that it's going to be what? The second block of that two-dimensional array, and within the two-dimensional array is going to, like this second 2 is going to be what? Is going to be the rows, and then at the first one, the last one to be columns, and then at the fourth it goes in that format. I don't know if it's clear. I've explained it well. This topic I was to discuss it there was a time that I was to discuss it, but up to today I've never had a chance to explain the axis. But I believe you've understood what I'm talking about.
Run the cell we see.
Okay, let me use, first of all, I was talking about the two-dimensional array, and so guys, you can see you can see now the output is now a two-dimensional array. Is a two-dimensional array with four. I specified four. That's why it's containing in each column, or in each row is going to contain like a four columns. You can see actually four elements. One, two, three, four. Yeah, that way. So basically, this one represents the axis. You can see earlier when you just use 5, it's going to represent what? It's going to represent one-dimensional array because axis is only there 1. Is that clear?
Yes.
Yeah.
Yeah. Okay, thank you. Now, okay, sometimes you want to generate.
Nema,
Yes, yes,
can you see that code that you've just used now?
yes, yes.
No, the other code down there.
This one.
No, yeah, that one. Can you
Mm,
copy that code,
mm,
the entire of it,
mm-hmm,
paste it in that cell.
mm-hmm,
Just put it in that cell,
mm-hmm,
right?
mm,
You see how we're having 2, 4.
mm.
Just put a comma and then say 4.
4. Okay.
Yeah. Can you just run that and then explain that?
All right. So the first argument here, 2, defines how many number of blocks. You remember, a two-dimensional array is a three-dimensional array because you can see we have three axes. These numbers here, separated with a comma, are called the axes. Because the three-dimensional array is an array that contains two-dimensional array as its element, right? So this one means in that two-dimensional, so the first one, it defines the number of blocks of two-dimensional array. Like you can see, this is the first two-dimensional array.
Okay, okay, yeah.
Hmm,
The one that you have highlighted is the
hmm.
first block.
Yeah, it's the first block of
Okay,
the
thank you.
two-dimensional array. Then this is the second block of the two-dimensional array. If it were 3, let me try to add in 3. 3. So essentially, this will mean that the blocks will be 3. So the first one represent, if it is in a three-dimensional array, this one defines the first block of the two-dimensional array, because we say that a three-dimensional array is an array that contains two-dimensional array as its element. So this, in this three-dimensional array, the first two-dimensional array as its element is this one. The second one is that one. And then the third one is that one. And then the other parameter here, now we are now in the two-dimensional array. And we know that this axis in a two-dimensional array, so this is the first axis in a two-dimensional array, which stands for what? You can guess.
The rows.
Yeah, the rows, and then the columns. So the rows are these things. This is the first row, second row, third row, fourth row. And then the columns also there are 4. 1, 2, 3, 4. That's why you get such an output. Is it clear?
Yeah, it's clear, Nema.
Okay. Hello. Can you guys hear me?
Yes, yes.
Okay. So I have a question.
Yes,
What
yes.
if you wanted to specify the range of number for like this this float, like say 0 to 2? How would you do that? This is just 0 to 1. Like the range is from 0 to 1,
Oh, actually, I'm going
right?
in. Yes, yes, yes.
Oh, yeah. Okay, I'm going to explain that, right?
I'm going to explain that. For me, I always
Okay,
like
okay, okay,
trying to go from the bottom up. In Kenya, we call it bottom up
okay, okay,
approach.
okay,
Yeah,
okay, okay,
yeah. So,
okay. No problem.
okay, you're welcome. So I think everyone is good at this one. I don't know if I can add in a comment, but I don't know. Let me just use a different one here. And basically, sometimes you want to generate a random number from an array. So we have another method called a choice. Remember, when I talk about method, you understand. Anyone who can define for us what is a method? Any sharp student there? Actually, I'm waiting for you to kindly make me utilize a lot of time here. I don't have time. I have limited time. We explain these things in many, many, many sessions, so you need to know these things.
Hello, Nema.
Mm.
I don't have forgotten personally, let me just be honest with you. But what I know is that when you have classes, you have methods in those classes. But
I think that's correct. That's the answer
yeah,
that
you
I
have
wanted.
method in those classes. So I've forgotten how to explain that.
Actually, you are correct. So any function that is defined within a class, we call them the method. But the function, these are just independent function. You just define a function with a diff keyword. Is going to be a function. But a method is a function which is defined inside a class. Yeah, and I think you had a very, very serious discussion on classes. So people shouldn't be quiet that way. But give me some second here. All right. So I think we were there. Where were we? Mm-hmm. What did I say? The last point.
You are
Oh,
talking about methods.
oh yeah. I was talking about the method. So basically, we have a choice method which allows you to generate a random values based on the array of values you have. So I think you now instead of like specifying integer or what, you are going to use here a method called choice. Remember always to begin with the method, actually the module, because this function is only available within this package, this module. So you have to always begin with the package name, then the choice. So this way you can specify like for example, you want to like, for example, let's an example that I used, the first one was, for example, you have a box that contains 10 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So within that numbers defined range, you want to just pick a random number. So you can use that method choice. It's just semantic, it's just descriptive. Choice, you can specify. For example, let's say we have 3, 1, 2, 4, 5, 6, 1, 0, and whichever value it is there. So basically it's going to return a random number based on these options you have here, right? So let's try to run, and then you can see it won't generate anything. Even if you run it a million times, it's not going to generate anything outside this scope, outside these values that you've defined here. So it's going to generate the numbers that you have defined them in this one, right? So you can as well specify, for example, if it's a two-dimensional array, because it also takes in it is arbitrary keyword argument. So you can add in as many as you want here. You can even specify the size. For example, the same. Let's just use. And I mean, when I use the size, you understand. The size, this one defines like the shape of the array to be returned. So, for example, if you add in these two values I've just explained, it will be a two-dimensional array. For example, 3 rows, five columns. So it's going to like contain 3 rows, then 5 values. But the range, the range will contain values which are here. You know. So let me let me do what? Let me do what? Let me run, sorry. Let me just run. And then guys, you can see now the shape. You can see the values are within this range. And because it's taking random numbers, you can see even 0 is not appearing here. But if I run it again, you can see 0 appears. So it will just generate a random number anytime you run. By the way, there's sometimes you want to like be consistent. I'm going to show you, make sure you remind me I show you that. So sometimes you might want like to use an independent like default, how can I put it, like persistent with the number of random. And okay, for example, you are testing something, you are doing some hypothetical, what can I call it?
Hypothetical.
Yeah, hypothetical testing, right? So you might want like to be consistent so that you can test different scenario. So I'm going to show you also that you can specify you can specify a seed with a seed method. Let me just show you that. And in that case, I think you also need to use the numpy module. Let me use a numpy module here. So import. Remember this one we are just importing random alone. But if you say import numpy s np is going to generate to like you are specifying the whole package that contains with everything. So first of all, I'm going to import that one because I'll use the seed within the module within the numpy random, and then let me also specify the um, you know, or which one can should be start. No, the positioning is not like a matter, but I'm trying to be like organized. So you can specify the number of the you can specify the number that, for example, you've generated certain output based on your random. You want to be consistent with that number, so that anytime you run, the number are still the same. You can use this method from random called a seed. So it is random. Sorry, what am I writing? So random then a dot seed, and then here you can specify any whole number to initialize it. But in most cases, when you go to many documentation, they usually use 42. But I just read some parts in the ALX, the content there, they used 0. You can just use any whole number here to initialize it. And then, for example, let's just generate some random number, and I'll use like for me, I don't like doing what repeating things, and you'll forgive me for that. So now this x, let me try to be descriptive this time. Let me just call it random underscore numbers, and I guess you can guess here I'm using what the snake case naming convention, and then I'm going to assign here to now I'm going to use now np and dot random dot rand, and then let me just use what let me just use let me just use because this one specify, let me just use the values between 0 and 1, so I can specify the range. Let me just use, for example, something like 5. Actually, the number of the numbers to be returned, or are the elements within that one dimension. Because I'm using 0 axis, it means that one axis, basically this one is one axis, so it should be a one-dimensional array. So remember, when I don't specify, it will return a single value, a scalar value, because it is a 0. You don't specify anything. It's going to be 0. The value is going to be between 0 and 1. But if you specify here, it's going to be a scalar value, one-dimensional array, one-dimensional array with 5 rows, or a 5 columns, or a 5 elements. Let me say elements is a better one. So I can I can write here. Let me just use a print, and then I'll try to be as descriptive as I can. Yeah, so where was I? Actually, there's some things here that is disturbing me. So where was I? So let me just use your string, and then perhaps let me try to say that random numbers with seed. Remember, we're using seed there with a seed of I used 42 the other time, so let me say with a seed of 42, and then perhaps let me try to add in what trying to add in some space here. Then here I can pass that variable here. So you'll notice. Let me. So this is the first one. I think I can run it, and then I'll create another one, and then you'll see. So this is the first output. Let me try to run it again. Let me try to make it add a comment here. So the first random numbers, and then I'll copy the same things. What I'll change is just like the variable. I just changed the variable, but I remember the seed I'm using the same because I want to use the same number that was initialized here. So in this case, I'm going to just change a number. Let me just call it second underscore random number. So here you should also say second underscore random number. So let's try to compare. Let me call it same, for example, same random numbers with seed 42. Let's try to run and compare. So guys, you can see the output is the same. You can see let's check the last one. You can see it begins with 0.15, it ends with 64. Can someone affirm this one? Confirm this one?
Yeah, the same.
Yeah. So I think understanding this concept is also very important because sometimes you might want to do some hypo. Can someone try to? I'm not good in English, by the way, and also spellings. Hypothetical testing. I think I've nailed it, right? Is it hypothetical testing?
You got 100%.
Wow, thank you so much. So, so sometimes we want to be consistent with the number of random. You're generating random.
Nema.
Yes.
John Warutere. I like calling you Warutere.
There's no problem. I'm asking Nehemiah.
Yes. Any can work.
This seed.
Yes.
What is it exactly? The seed 42, because it is creating the same numbers. What does it?
Actually, is the one to, like I was trying to say, for example, you want to use the same number of outputs that has been generated in the first random numbers. You want to because any random number, when you run it again, it will automatically change. For example, let me just use an example of this one. You'll see that anytime you run it, it will change. But sometimes you want to be consistent. You want to use the same output because maybe you are doing some testing there. I don't want to use the other word. You are doing some testing. You want to check on things. So you don't know. You can't. This one can't give you the correct when it is changing all the time. So this seed function or a method, it helps you to initialize a value of which a random array or a value of which it will be consistent, in your testing or a use case. You want to, it can be anything. In fact, you can even use 0. This is just the value to initialize. You can see the output is still the same. Even if you add in another one, it will just be the same. I don't know if I've
So maybe to add on that, it's like that. Maybe to add on that, Warutere, in statistics and in this sampling, you might have a big population size or a big data set, and you want specific sample items. Let's take a smaller sample. Let's say you have 10 people, and you want to test how they behave. So you just need 3 people in that group of 10. and you want to call these people every time in the functions as you do your coding. You remember you will need maybe to refer to this number each and every time. Maybe let's say you are calculating their mean, and ahead there, after a few steps, you want to calculate their standard deviation. You will still need to look for those numbers. So to avoid every time you generate these random numbers, you pick different items, you lock those numbers because you don't know them. You can't see them, especially for large sample sizes. You cannot really know what did I pick, what are the numbers I'm working with. So once you lock like that with that seed, you are sure that it is working on the same sample size each time.
Okay, thank you. So you mean it keeps the sample size constant. So
Yes.
for every statistical analysis I do, I'll use the same numbers.
Yes.
Okay, thank you.
I thank you so much. You've saved a generation there with that powerful explanation. Thank you so much. So I think we now need to do away with these basic things and begin to discuss the distribution. So what is data distribution? Anybody who can guess or maybe tell us the definition?
Mama, bana, today you're on our neck, but let me just try.
Yes, yes.
Today you're on our neck because you've said that you're not speaking unless we answer questions, so no
Yeah.
problem at all. So, first of all, for me, I think that a distribution is like a pattern that the data follows. Because we have the Poisson distribution, the binomial distribution, the number distribution. So it's a pattern that the data follows, or the mean of the data. Hope I've said something which is correct.
Yeah, that's very correct. Or maybe any other attempt, any other person want to add in some input there?
I can try.
Yes, yes.
I think distribution is how spread out the data or values are.
Yeah, that's correct. That is very, very correct. Yeah, all the definitions there is just correct. Very, very correct. Or you can still say that a data distribution is a list of all possible values and how often each value occur. And I'm going to show you in a few. And also I'll try to be, we shall be visualizing these things so that we can compare. We can compare each and every one of them. And then for people to understand, I want everyone to understand everything that I'm going to teach today. So make sure you do understand. Now, because today I'm using the the random distribution, you can simply say that a random distribution is a set of random numbers that follows a certain like probability density function. What is a probability density function? I think these things I talked about some days back about I was talking about the KDE and I talked about the probability density function. Anyone who can try. In fact, I also watched the discussion yesterday. I wasn't present, but I watched on YouTube. I think Ibrahim and Chebet, they talked about the probability density function. Anyone who can try?
I can try.
Sure, sure.
It's probability of a certain outcome
Mm.
within an interval in continuous variables, random variables.
Wow, wow, wow. You are very, very sharp. You know, you are very sharp. It means that things usually like uh, stick. There's that parable. I don't know if some people here are Christian, and that there was a farmer was going to plant, and then some seed fell in the thorns, another one in the rock, another one in the loam soil. So there was that variable, and I was trying to like put it into you guys. So for Lauren it's the loam soil, I guess. Yeah, that's very, very correct, Lauren. Thank you. So basically, a random distribution, basically the probability density function, just as Lauren has said, is a function that describes the a continuous probability, because random is it deals with probabilities, right? Random deals with the probability, so I can say a function that describes a continuous probability of all values in your array. So we can basically generate a random numbers based on and they define the probability using the choice that I used somewhere here with this choice method from the random module. And then this choice method allows us to specify the probability for each like value. I think I'll just use the same. I'll just use the same values here because I told you earlier that I don't like repeating myself, thing that I've already written. So, so this is the let me try to reduce it to something like a 4. I think 4 are best to work with. So these are 4 numbers, or basically the outcome should be based on this array here. And then now to define our probability, we use the p. P actually to define our probability. So it is an argument defined within that choice method. So I'll say, for example, P, then I can assign here to. Now, when you are defining a probability, you ensure that the values are the same. Not the same, actually, the length are the same. So here, I'll use a range here. And then remember for probability, who can tell me what is the range of a probability? How does it range between which value and which value for probability?
0 and 1.
0 and 1.
Yeah, that's very, very correct. So it means that when you are defining a probability here, so your value should be within 0 and 1. So for example, the first one, the probability for it, I can give it, for example, 0.1. The second one, let me use something like a 0.3. The third one, I can give it a 0. 0. Let me try it to at least 6. And then the last one, let me give it 0.0. So who can tell me what will be the probability of this? Remember these things they represent each other. They should be the same. This 0.1 stands for these 3, and then this 0.3 represent this one, and then 0.6 represent 2, and then 0.0 represent 1. So who can tell me the situation about this 0.0, the probability of these 4?
It will never
To
appear.
make the total 1.
Yeah, it will never occur, right?
Yes.
Yeah, let me just use the size I can give it even something like even 100 is not bad. So and then I think it's clear. Now let's try to run, and I remember that parameters are always separated with a comma, and for me I had already forgotten that, so it could have thrown an error. So let me try to run. So you can see now in this case, let me try to reduce the values to, but I think it's clear. But now, guys, you can see there's no 4 somewhere, right? Because the probability we gave it 0.0. So it means that there's no at any point that this 4 will be presented, will occur. Yeah. So you can see because we gave it. Let's try to give it something like a 5. 5. You can see in this case, I think 2's 1's are so many. So let's this time try to give it 0. So you'll see that you will not see any 1 in it. It means that, okay, sorry. What did I do wrong? Okay.
The P is more than 1.
It's more than 1, yeah.
Oh, sure. Remember also by the probability, the value should be within like that range of 0 and 1. Actually, the values when you add in all of them should be 1. So I think I should have used here. Which value was it here? Let me try to use values that are consistent. So 0,
Okay.
0.0, then a 0 point, a 0 point, point. I want to use some intervals here that will sum up to 1. Who can give me some random values that will add to 1? 0. I want some values.
0.2, 0.6, 0.2.
0.6. And also remember that the values
But 0.4.
0 point
You've written 0.4.
0.4, so it should be 0.2.
6.
6. So also remember, as you're trying to make it like a big above like a 1, also know that the numbers that you're using here should tally, should have the same level here, like the number of elements should be the same for the output to work well. So I think if it's correct, you can see now we no longer have what? I think there's something that's not correct here because I wanted.
No longer have 3.
Oh, 3. Okay. I was thinking that it should be 1. Yeah. So guys, I think you understand the logic there. Remember that probability, the value should range between 0 and 1. So it should pass.
0.1 for 3 and 0.5 for.
Yes?
I'm saying you put
Yes.
0.1 for 3 and 0.5 for 2 so that you can have all the numbers. Maybe they can understand. Maybe they can see it appearing on the
I can hardly hear you. I don't know if it's my system voice or you are the one.
I'm
You can
saying,
yes, it's clear.
when you reach a 0.0 probability of 3, it means
Yes.
that 3 will not appear in the list that is printed out.
Yes.
So, for you to showcase the difference, you can put a 0.1 for 3 and put a 0.5 for 2 so that they can see all the values appearing and not the difference.
Oh. Okay, so 0.1 and then I hear 0.5 like that.
Okay.
Yes?
Yes, it's okay.
Yeah, so here it essentially means that the probability of 3 occurring is 0.1. And then this one is 0.2 in that hierarchy. And guys, remember that you can pass in any size of a dimension. Remember, this is just a one-dimensional array, so a continuous list containing 100 values, but you can specify the size. Remember, we talked about the sizes just in a few, but you can just specify any. For example, this is 3 rows, and then let's use 4 columns or 4 elements in each. And then so you can see the output. You can see. Now, let me try to use our 0. 6. So you'll see that you'll never see somewhere 3 in it. Yeah. So guys, just know that you can take any argument. And also before I begin like the distribution, I think let me talk about sometimes you might want like you might have some values defined somewhere and then you want to shuffle them. You want to like to shuffle and then select just a random number based on it. So like again.
Sorry, Nehemiah.
Yes.
Sorry for cutting you short. I had stepped out a bit. I was just asking, after printing that function, what does those output mean? Sorry, I was out a bit.
This output here.
Yeah.
Did you understood that part of the axis? The arrays?
No. In fact, I left whereby you were saying probability should add up to 1.
Actually, not
100. Yeah.
Not that part. There's a time I discussed about the the dimensional arrays 0, 1, 2, 3. You understood that part? How you can create like a one-dimensional array
I
based
think
on
I'd
a
stepped
random.
outside. I
You
think that
under
was.
you are not
You
present.
just said now.
Yes?
You just explained that part now.
Okay, I don't know if I'm getting you, but let me try to explain. This part you understood. There was one where we had, I think I should have used a different cell, but there's one. Let me just rewrite. This part you understood when it was this way.
Yeah, I left when you had when you were printing this output. So I've come back and there's some things which have gone on kidogo.
Oh, okay. Thank you. I think
Yeah,
I've
so even
understood
this
it.
part, the output, yeah, you had not explained this output.
Oh, so basically, whenever you have like this range, you want to like return an output based on this range, and then you want to assign the probability. Probability is like the possibility of an event occurring, but the value should range like between zero. Someone said that the value should range between 0 and 1, so it should be within the range of 0 and 1. So for example, when you give it 0.0, what can you tell about that probability when the probability is 0.0?
0.0, I think it won't happen. Like, for example, there you can see you have a 3. That 3 corresponds, because I left you saying that, the should I like using variables? Okay, those 0.0, 0.2, they should be the exact number with the ones that are on this choice. So basically, the 3 corresponds to 0.0. Then that means the probability of 3 happening, it will never happen. It's next to impossible. It's like waiting for things that will not happen.
Yeah. And then now this other parameter size defines the number of defines the shape of the array. So when you give it a scalar value, or when it has just one value like that, a single axis, it will be what? When it has one axis, zero, the one axis actually.
Yeah, I think it will just be like a long list. It won't like have rows.
Actually, I'm talking about the shape of the array to be returned. I explained earlier and you said you understood.
The shape of the array.
Yeah, the shape of the array that will be returned here.
Vin, explain.
One dimension. You are the one who stepped out. Me, I was here.
Yeah, so basically just know that the numbers here, if it's just a single number, if it has one axis, it represent one dimensional array. So if you have two axes, it represents two-dimensional array. Three represents three-dimensional array. I don't know if you got it, and I explained each.
Yeah, I've now remembered. Thank you so much.
Yeah, so for example, when you give it these 100 values, 100 values, it means that the range will be between 0 and actually the values will be like in the range of 0 and 100. The values, it should be
0 and
like
100,
100
0
when
to
you count all
99.
of them. Yeah, all of them should be in that range should be 100 values. And then you can specify any size. For example, I had reached a point where I was describing like a different size. Like it can also work on a different shapes. So for example, a two-dimensional array. Let me try with the 3 rows and how many columns? Let me try 5. You'll see nowhere where 3 will occur because the probability is still what? 0. Now let's see, we have 4 here. Let's try to make 4 also 0, that it can also be affected. Let me give it now. This should be 0 and then this should be 2. And as someone said that the probability should sum up to 1. So I think it is correct the way it is. If it's not correct, I think it will throw an error. So you can see even if you run it a million times, you never see 4 occurring because the probability you've set it to what? To 0. I think I had reached that point. Is it clear?
Yeah, it's clear. Thanks.
I think I want to talk about because time is fast moving, but I want to talk about this thing because this is once and for all. Let me talk about for example, you have an array. You want to to shuffle it. You want to shuffle it so that the output won't be consistent. You have just a normal list. I think let me just use use the code here because
Nehemiah,
yes, yes,
your 1 hour is over.
my 1 hour is over.
Your 1 hour is over.
Whoa. And I haven't even talked about the distribution.
You can continue.
Yeah, I think I'll try to go faster. Let me try to go faster. Let me just explain this one and then I shall go straight away to the distribution. So let me try to talk faster. Array, wow. I always don't finish. I don't know why. NP dot. Dot. Because for me, I always believe that people should understand things from scratch upwards. Because if you want to explain things, people will begin to ask question. What is what is what is a certain function in statistics and stuff like that. That's why I like putting people from the very basics to the advanced. So let me just talk about this one, and then I'll go straight away to the distribution. This is my normal value, 3, 4, 5, 6, 7 to infinity, and then I want to use again the random dot now we have a method that can convert this normal list to a random or maybe to shuffle it, to change the arrangement of element. So we have a method called a shuffle. Then you pass in your list, which we define it with array. And then let's try to print that. Wow, I don't know how to talk faster. I also to type fast. But
Don't worry.
One thing that I'll say,
yes,
Nehemiah,
yes, yes,
one thing is, we can adjust our time so that we don't rush like that. Most of the time,
yes,
getting the basics is always easy for everybody. Now, but when you rush on now the core concepts, it becomes so
yes.
complicated for you. You will find people will forget everything. So,
Mm.
as much as you try, just try to be within your best so that people can see and understand. Where we can't cover, we can always try and find some exercise. Because now this is the core thing.
Wow. Thank you. I think people in agreement with that. That I go slowly, but people understand.
You don't go slowly, just go with your pace.
Yeah, I'm my person.
Move at your pace.
Yeah, okay. I think now I'm now calm. I think thank you so much for reducing the pressure on my end. But I don't know why. Anytime I teach, I don't finish things. But let me hope today I'll cover something. So this is just our normal list. We want to shuffle it so that anytime we run it, it won't be the same the same output. So you can see the output is different whenever I run it. So we've just converted our normal list to be to be random, to make it return a different output. So basically you can use that shuffle method. Also there's another one called there's another one called permutation. You can try also that permutation, but I did the last one, the permutation. So this one also generates a random permutation of elements of this array here. I think the spelling is correct. Yeah, so you can see whenever I run it again, the values will be. Now, is it really the same? Let me try to. Okay, for shuffle it is going to return the. It's going to return the. It's going to return the. For shuffle it changes the number, but I thought also the permutation should work as well. But basically, the permutation is the opposite of shuffle. So, for example, you have values which are not I think I can use a different example here. Let me try to use the same code cell. So we know that this value should do what? This value here should return like where was I? I think I'm being confused. I think I should let me try to use now. We know that this one should return. It was shuffle initially, shuffle. So we know that the output here should be what? Should be shuffled, shuffled. But now if we want like to rearrange in the original array, we use now the permutation. I had forgotten. The permutation is the opposite of the shuffle. So it should be a random dot permutation, permutation, and what? Random dot permutation. Hey, my goodness, today is today. And someone told me to relax. I don't know what's the problem here. I'm trying to delete this thing is not. Let me try to do this. I create a new one. Yeah. So a random dot permutation. But I'll make sure I talk about the hypothetical testing. I think that's the pronunciation. I try to talk about that one. As much as I'll talk about this distribution, I'll try to before time ends. I think in 20 minutes time, I think you should tell me to talk about those things because we are not sure if we'll meet again. So it's better I cover something there so that I think you have like a clue on that. So um uh-huh. Oh, basically this one is coming after like we've shuffled like now this should be the output. This is the output here. So this taking it is the original output here. But I think let me create a variable for this one so that you can see there's a difference. Let me call it. I want to use something that will make sense. You'll understand better. But I think you should just know that this one is the opposite of the shuffle. The permutation rearrange it. I think that's clear. I think I should just because when I try to explain this thing, I don't think if I'm trying to make sense when I try to explain this one. But just know that permutation rearrange the shuffle. When you've shuffled, it's going to rearrange it. Is that clear?
Yes.
Yeah, so I think straight away I want to begin now the different distribution here. And I'm going to use a module here.
Nehemiah, I have a question.
Yes, yes.
How do you use that permutation and shuffle in real life? Like, let's say in a real world scenario.
Let's assume that you have a data. You are like you have done what? Let's say you have a data set, right? You have a data set and you want to make the data random so that the values won't be arranged in a particular sequence. So once it is random that way, you want to be consistent, like you want to use that random value to do a different analysis, but be consistent because anytime you run a shuffle, it will be a different output. So whenever you use now that permutation, just like at the seed, whenever we were using the seed the other time, so it like make it consistent. It will persist so that you can use that value. I don't know how I can relate it in a real life situation, but I don't know if it's clear. Like if you want to you've shuffled already, but I want to be consistent on that random value that you have. It will maintain like it will save that random value that is generated, that random array. Is it clear?
Like shuffling cards when you're playing cards.
Yes, something like that. But now after you've shuffled, you want to stick to that shuffled data. It's different from the original, but now whenever you want to use it, you want to maintain that shuffled data that way.
Okay.
Yeah.
Thank you.
Okay. So I think I want to talk about the distribution now. And I guess I'm going to use a module here called Seaborn from Matplotlib. Matplotlib is a low level a plot in library or a visualize in library. Under it, we have Seaborn, which is built from matplotlib. So the Seaborn is like a deeper. It is like deeper compared to matplotlib in terms of visualization. It's like an advanced of Seaborn. So if you don't have like that Seaborn in your system, you can always install with the pip install Seaborn. Is a package built from mat from what from matplotlib. Yeah. So that's how you can download it. You can download it in the system wide. I think it's clear. People know how to download it. System wide the command line. Sorry guys. CMD. You can install it in the system wide with the command pip install that Seaborn. Because for me I already have it. Seaborn. Today I'm so confused. So when you run this one, it will install it into your system. So this is the one that I'm going to use to like compare different type of distribution, actual distributions, because I will be trying to visualize so that people will understand very well. So I think let me add in a comment here and then let me call it data distribution. And we are going to begin with a normal one. I'm going to begin with this random, then we shall advance maybe later to discuss about statistical distribution. At the moment, I'm just using this random, but you relate the concept. If time will allow, I'm not sure about the time, but we shall talk about the statistical distribution later. Perhaps I'm just using the random at the moment. It's called the normal. We are beginning with the normal. I think let me add in another one. Subheading called random, normal, sorry. I've talked about the random so much, so sometimes people call it Gaussian distribution. Gaussian distribution. So this, I think this one is what is mostly used in many events. I think this normal distribution is what is, for example, you want to like identify something like is it BMI? Something like a BMI or something like, for example, IQ test, heartbeat, things like that. You'll basically use the normal distribution. Now in random, you use the method called normal. I remember at the moment I'm just using the random. We also have the statistic version in the SciPy. And by this, SciPy is very powerful. Is someone talking? Someone can try to mute because I think I'm distracted. One who is not muted. Okay, thank you so much. So this is a probability distribution. This like it fits the probability of like distribution of like many events, many events. It is mostly used. In fact, even the testing I'll be using this one. I think today I'll use this one to show you that part of the hypothetical. Is it hypothetical testing? I think so. It takes three arguments, specifically three arguments. These are what we call the keyword arguments. So anything that you are limited in a function, you call it what? Keyword arguments. And something that you are not limited, the number of arguments to pass in, the number of parameters to pass in, we call them the arbitrary keyword arguments. So you can see the other one we had, like you can add in as many arguments as you want. It doesn't throw an error. But now for a keyword arguments, sometimes it's shortened with quags. Quags, it means that you are restricted the number of key value pair that you are going to return. So this is keyword arguments. So the parameters, so I think let me just add in a comment here. Let me just say it takes three parameters. It takes three parameters, i.e., let me use a code lock. Now this lock this log is like the mean, where the peak of the bell exists. Like for a normal or a Gaussian distribution, the shape is like a bell shape. I think I'll show you just in a few. But let me type here the explanation. This is like a mean, or where peak what's the spelling for peak of of the bell exists. In case I've wrote my things, just tell me. And then on the other one is a scale. Remember this one, I'm just using this backtick to symbolize because this is a markdown to symbolize a code, but just scale. For example, when I say scale, it's just scale, not like with the quotes, with the backtick. So this scale is for standard deviation in a random. Remember, it is defined several ways in different packages, like in SciPy and different ones. So this one I'm specifically into random. So this one is standard what? Standard deviation. I think sometimes you can just respond to anything to know that I have people following. Sometimes quiet makes me become nervous, knowing that I'm just talking to the computer and perhaps my internet. By then, my internet today is not stable. Yeah. How flat the graph should be, or a graph distribution. What's the spelling for distribution? Or I can just say distribution without typing distribution because I realize I have issues with the spellings. Distribution, and then the last one I think now is the size. I think you understand the size. Do I have to explain the size? That's the shape of the returned array. Can be what? Let me just say shape of the return array. So it can be one dimensional or that or any other. So basically these are the arguments that that it takes. So but if you do not specify these things, it will have like its default values. I think now first of all let's first of all try to generate a normal distribution without any other parameter here. We just like the size there, we specify the size and just return it, and then we shall pass in like because I want us like to receive first of all the output, and then we shall specify the log, where it means the mean, and then scale, the standard deviation, and so forth. So I think at the moment, let me just import first of all. Is someone talking?
Omar, kindly unmute.
They should mute at the moment, or maybe.
Mute, sorry.
Yeah, thank you. Unless you want to talk, I think you can. I said that to make me see I have people. You just say something, but I don't mean you unmute, continuous. You can just say yes, yes, we are following, something like that. But like don't leave it. Let me just say X, then I'm going to assign here to random. And the method is self-descriptive. For example, normal is just normal. Just type there normal. And then the arguments that you can pass here is like for example, the log, the scale, and the size. So these are the parameters that you can pass in. These are the parameters and I think it's arbitrary. By that it's arbitrary because you can specify any. You can specify like for example, if it's just the scale, because we are using the random. It generates like automatic. So for example, you can just specify the size. Let me pass in the size first of all, and then we shall specify like the output that we want, and then we shall try to visualize and see how it will look like. So for example, let's try to generate a normal distribution with the size of 2 and something like a 3. Let me print print what? Print X, and then so that's an output that I have here. But now let me try to define this scale so that I can try to visualize it. So let me specify other arguments because I want to like visualize it so that you can see the shape, how it will look like in when you are trying to visualize it. I say that it is in which shape? It's like a bell. Uh, it is like in bell shape, a bell like a curve. Yeah, we shall see. I think once we see it, you'll understand it better, or I'll explain it better. So the log, who can tell me what the log means? Stand for? It's just there.
Mean, mean,
Thank
mean.
you. Thank you. And then scale. That should be standard deviation. Yeah, just talk and anything. Yeah, and then size we've given it that one. Now, so this is the like the values that we have, and I want to plot a normal distribution based on this data here that has the the mean of 1, a standard deviation of 2, then this is a two-dimensional array. So basically a two-dimensional array, it means that you have the x, I have two axes, the like for x and the y axis. So let's try to use now the matplotlib things so that we can understand these shapes in details. I'm trying to be fast. So first of all, we're importing the module because we are using the module. Or let me just copy paste. So this is like the graph that I want to visualize this normal distribution, and then see the shape. So this is the this module random, and then the second one is from, and let me say import matplotlib.pyplot. Is most cases they usually use PLT, and then also we need to, because I'll use also Seaborn, let me say import Seaborn. Seaborn is SNS. Is SNS. I think they usually use this. SNS as an alias when you go to the documentation. Now, so let's try to like plot. So this is the variable. Let's try to plot like this graph and see how it will look like. So I'll say SNS standing for the package Seaborn, and then a dot dist plot dist dist plot, and then I'm going to pass in what? I'm going to pass in x. I'm going to pass in x. Or let me do this. I think at the moment, let me just, instead of defining this stuff, let me just use a symbol one here direct so that you can understand. Let me just use a symbol one because I want to have a lot of data here. Let me just, in fact, let me just pass it, or I can let me just pass here size again, only size. Size is going to be a one-dimensional array with the values, for example, something like a 1000, so that we can see the distribution very well. And then if you don't like specify the histogram, it will come in a histogram, but I want it to be like in a bell shape without the histogram to be like a just curve without the histo thing. So we need to add in this hist. You assign it to false boolean to return to be like to contain nothing. And then now on visualization, we don't use now the print, we use the PLT, the alias for the package pyplot from matplotlib, and then dot show and dot show function. I guess it should be correct. Yeah, let me try to run and we see the shape. I believe that the shape should be correct. The code is correct. I think let me give it some how many minutes? Oh, the normal got, oh, basically, sorry guys, I should have passed it because here I'm using like as a variable. I should have used to it. I think the best way for people to understand, let me just pass it direct. Let me pass it direct so that you'll understand it better. So this is the first, like, so let me just pass it direct inside. So, at the end of it, guys, you can add in also another argument. So this should always be outside. Outside. Because this is in the size. You can't add in like you can't add in the false because the size is this is the shape of the returned array. So you can't add in also inside the other arguments like that one that we had here, the histogram. So the histogram is an argument in the normal. So let's try to visualize and see if it will plot. So guys, you can see this is what I was talking about, the bell shape. So it looks like a it looked like the bell curve. They usually call it in the bell curve because of this its bell shaped distribution. So I think let me just quickly talk about these. I think I can talk about three of them and then I talk about the hypothetical testing. So I think the other one I can talk about is the binomial distribution. I think I'll use the same code. For binomial distribution, the binomial distribution is a discrete. Remember for normal, remember for the normal distribution, this is like how can I put it? A discrete, the opposite what is it's what? Continuous, right?
Yes.
Yeah, continuous. Yeah. So for what? For these other for binomial, this one is a discrete distribution. So for example, you can have like for example, let's say that you have like the output the outcome should be like a binary. For example, you are like let's say you are tossing something like a coin. It will have only two. It has two probability, two options, either the head or the tail. It has like only two options. So it has three parameters. I think I should have created some what? Let me copy these codes here. And then guys, here I should have used our thing. But let me use a line break instead. Backslash. Yeah, so and then let me create a new one. So this should be now this one should be binomial. Binomial, this is not Gaussian. This is just binomial. Binomial distribution, this one is a discrete distribution. It like the outcome are two, like the outcomes are only is binary, like a two like either the probability is half. Let me use that example. For example, you toss a coin, it will either be head or the other one. So and then the parameters here is it's not log. This one is n, which defines the number of trials that you want to like toss that coin. You want to how many times you want to toss it. So this, let me say, number of trials. Trials. I think this is spelling. And then the other one is their probability. Their probability. P that's for probability. Let me just say probability. Probability. I think the spelling. The goodness I have these these it usually suggests for me because I have issues with the spellings. I think that's the advantage of this feature. I like it. So let me also add in the breaks. How many minutes remaining?
16. Oh, sorry, 26 minutes.
Oh, 26. I think I'll talk about around 3, and then I think I'll talk about the our thing, to be fair enough, because I don't think tomorrow I'll be here. I won't be around. I'll visit someone who is in ICU tomorrow, so I won't be around. So we have
Nehemiah,
yes.
just scroll up a bit. You said Seaborn is the advanced form of matplotlib, something close to
Yeah,
that.
yeah.
Why are you also importing it yet it can do what matplotlib can do and even more advanced stuff?
Atuitimbo what?
To import matplotlib, yet you're saying Seaborn is an advanced, you can still use Seaborn.
But still, it's under matplotlib. You can see something like to visualize. That is a function within matplotlib. So it's just like how can I put it? It's like
Like the
an
way you
extension.
does.
Can
Yes.
Seaborn visualize?
Yes. No, we usually use now the PLT for function and the definition of stuff, shapes, and the plots. We use now the Seaborn, and then we to visualize we now use the matplotlib.
Okay, that's clear.
Yeah. So we understand. I think this code should be somewhere here at the bottom. Let me copy, and then I think I should cut it. Yeah, so you can see the number of arguments should change. I think let me pass here the variable. Can I use a variable now? Are you comfortable if I use a variable? Or I will confuse it again. Can I use a variable? Because sometimes I like, or let's just stick to our ways. So the argument that you pass here is n, the number of trials, then the probabilities, the probability. So like the outcome won't be like an array like the other one. This one is they have like a two, like two option. Let's say we have the number of trials that we want to run is to be like let's say we want to do 10, and then the probability always should be 0.5. Remember, should be half, either head or tail. Then the last one is the size. For example, at this juncture, I'm just using a size. It can be, for example, a size like the number, like the range, and the range that you are going to use there. For example, let me say size of so the value should be within 0 and that one. So now let me try to visualize this one. Not to visualize. First of all, I think let's first of all print out and see how it will look like. Let me comment this one. We see. Or should I run it direct to visualize instead of doing a lot of processes there? So I think the only thing that is changing here is just the is normal to. I remember it's just self-descriptive semantic. You can just type there binomial. Binomial, and then I think first of all, let's see first of all the outcome. I think I should let me do it like the way I did the other time so that you may get the flow. Let me copy this one. Not this one. There's another one. I'm trying to find a way on how I can explain it well, but let's just stick to this one. I think let me just generate a random with the binomial. Let's just visualize it straight away, and then now I think let's use 10. Then the probability, I think I can try to increase the size. Let me try it because we are visualizing. I want to have like a big plot, and then the last argument here should be, for example, if you want like for example that KDE, the kernel density estimation. If you want it, you can specify. If you don't want, like you can give it a false. let me give it a false at the moment, false. And then let's try to visualize this one, and we see. So guys, you can see the outcome. So I think you can see it's almost similar to, it is similar to the normal distribution. If you have like a large, if you have like a large data set, or maybe you have a lot of data, it will be similar to like a bell shape. It will be like the binomial. I think let's try to visualize everything, then we shall try to compare like the differences. So let me just copy also for normal, then I will try to see like the differences. Where was I? I think let me use it because I might want to refer to it later. Perhaps let me just use a new
Nema, can you just take the one to check to look at that code for binomial, that one?
This one?
Yeah, I'm looking at that code at 1,000. Okay, thanks.
All right. So let me add it somewhere. And guys, there are so many, but I guess for the interest of time, I'm going to use just two of them. Like a three, I think I'll talk about another one, and then I think I'll do it. I'll talk about that thing for the testing, to do the testing. I think that's very, very important. So here, I think let me try to increase the values here. Perhaps let me try to increase to something like a 100, so that we can have at least some huge size of data. And then so I think that's the only thing that I've specified. Or here, let me try to also add in other parameters. Like here, I can also add in, for example, the log. Let me specify, let me give it something like even 50. And then scale, I can assign it to 5, something like 5. And then the size 1,000. And then I don't want to have the histogram. I want us to see like how it will be. I think also I need to add in the labels so that we can tell which one is normal, which one is a binomial, which one is normal, which binomial and normal. Sorry guys, yeah, I need to finish with the. So let me add in the labels. So label, and the first one, this one is normal. Normal, so it should be. Let me give it a label, a label of normal.
Labels is LABEL.
Wow, thank you so much. Thank you so much for that. So yeah, repeat the spelling. LABEL, like that.
Yes.
Thank you. You know, I always have issues with spellings. Yeah, that's why I like. This one, I think I'll give it this should be binomial. Binomial. Should be binomial, not binomial. Binomial. I think this is the spelling. Am I correct? Binomial. That should be the spelling.
Yes.
Yeah, basically.
Yes.
Yeah. So basically, the idea here for me to use like this large size, I want to compare for an example where you have like a large data. It will look similar to the bell the bell shape. These are binomial. Let's try to run. So I think I should have removed the histogram somewhere. So let me try to. There's something that is not correct, that I think I can try to, so that it can have the output that I want. Let me just check, and then I'll think the log to be 50.
Are you supposed to print both of them at the same time?
Yes.
Oh, like both the normal and the binomial at the same time.
Yeah, I want to like have the same visual so that we can try to compare. we can compare. But let me check it and see why I'm not getting what I want here.
Nema, can you just kindly post that code in the chat?
This one. I think let me figure out the best one, then I'll share the correct version. And to be this
While
one.
Nema is checking, I'm home, guys.
Yes?
While
Yeah.
Nema is checking, I'm home. I didn't
You
talk at
forgot
the
you were
beginning of
traveling.
the feed.
Jolene, welcome
But you
home.
guys agreed to meet tomorrow. Didn't you guys agree to meet tomorrow? Why are you making Nema to go so fast? I thought in the group you guys were meeting on Saturday also.
Let me try to visualize one, and then I think.
The Nema,
Yes, yes.
the KDE, you should
Oh,
be true.
by the way, thank you so much. You're very, very keen. Thank you. Yeah, I forgot to change here because I don't want like that to show to display those things. So I should have given it true. Then my true also has issues. Yeah, so guys, and I think the histogram I should have also, but you can see when you have like a very, very large data set, you can see the shape. And the shape is like similar, is near similar, is just near similar. I think the main difference is that the normal distribution is continuous, whereas the binomial is discrete. Guys, should I pause here and then try to talk about though we have many others that I haven't talked about. We have the Poisson, we have the uniform distribution, logistic, exponential, chi-square. We have many, many others, including the Pareto, Rayleigh. There are many, many of them. Should I talk about the testing in a few so that I think you'll get. I'm not going to talk about it in details, just the basics so that you can understand the concept. I think on this one I've rushed. I don't think people have understood well, but I think we need to create another time and discuss these things in details.
Kindly share the code, Nema.
Oh, sorry, I had forgotten already. Sorry. Yeah. Wow, and the attendance nowadays is very good. I really like that one. Yeah. So, yeah. So, guys, what do you think? Should I continue with the distribution, or I should touch on the what? Hypothetical test. Should I talk about
Are
it?
you guys not meeting tomorrow? That's my question.
Nema had said tomorrow is not available.
But anyone who can be available, I think someone else who can teach, can present perhaps tomorrow. Anybody who will be present can maybe talk about just me who is not going to be present, but it doesn't mean that the meeting will not be there. So anyone who can present, I think you can have a session tomorrow. For me, I have someone who is so sick. I need to go there tomorrow.
So we need 2 hours on hypothetical testing, or how much time do you need for hypothetical testing, Nema?
I can take even 10 minutes or a 20.
I think we can do it right now. You can finish by 11.
Okay, I think you'll notify me whenever.
You finish by 10 for 45, and then people ask questions or something.
Okay. I think you'll just inform me
Okay,
when the
kindly
time
proceed.
reaches, because I'm not good at time management. So let me talk about the significance test, or sometimes you call it the. Now, there's another module that I don't think we have ever had the time to discuss about is SciPy. SciPy is for scientific, like a computation, deals with things with statistics in details. I think we'll need to create time in future. And I don't know why the ALX, the usual or the Explore team usually uh, use these packages and they haven't taught. I think it's a good idea always to like teach before you make people because I'm assuming someone who is a beginner and you are introducing the this module and you haven't taught. I don't think that is always a good idea. But anyways, within the SciPy for scientific computation, we have a sub package called as stats. So okay, I don't know if someone was asking a question, but now in statistics, the statistical significance means that the result that was produced has some what? Some reasons, or maybe has some meaning or a reason behind it. It wasn't like produced, randomly or by chance. So we have this module. I think I should show you how you can import. So to install, let me zoom in a bit. To install the Seaborn, you just again run the commands. It's still a Python package, so the commands are the same. Pip install SciPy. This is strictly for scientific computation. It's very, very powerful. I think if we will ever have time, we shall talk about this SciPy. It's very, very interesting and it's a very, very powerful module to use. I think for me, because I had already worked on it earlier, I already have it installed. So before I talk about that, within that module, when you install, it will come with other packages, some sub packages, and one of them is stats. Stats is a function for performing the statistical significance test. And when doing the test, I think this is where now I reach to that hard name called the hypothesis. I think this time I'm pronouncing well. Hypothesis, hypothesis, hypothesis in statistics. Yeah, hypothesis. I think it's clear. So basically, hypothesis is an assumption about a parameter in in a population. Ibrahim, can I use you an example? Not in a bad way.
Kindly use me. If you want me to explain a hypothesis, then let me know.
Okay. So basically, let me assume that we have the webinars that have been happening from the Explore team, and it usually happen twice a week, right? So because Ibrahim has never failed to attend a webinar, we can say that the probability of him attending the next two webinars the other week is is 100%. So that is just an hypothesis. Can someone pronounce it well so that I get the proper pronunciation?
Hypothesis.
Hypothesis. Thank you. Hypothesis. Yeah. So this is just an assumption. A hypothesis.
Ray raised his hand. Maybe he has another hypothesis.
Yeah. Sure.
Ray. I think that hand is misplaced. Let's proceed.
Okay. And also, thank you so much for the proper pronunciation there. So, hypothesis, I think that's the correct word. In case I use it in a bad way, just correct me. So, now this is just an assumption about something because we know that Abraham or Ibrahim has never failed to attend the webinars twice a week. We know that the probability of him attending the webinars next week twice is 100 because based on the previous data, based on the previous attendance, we can guess that the probability of him attending the subsequent webinars in the other week is 100 based on the data that we had. So that's just an hypothesis. uh, hypothesis, hypothesis. I think I should find another word, hypothesis. So that's just an assumption about his attendance, on the webinars. So on the hypothesis, we have like it is divided into two categories. We have the null hypothesis, and then I will have the alternate hypothesis. So, for example, for this null, this assumes that the observation is not statistically significant. Like you just assume that you think that, and you think that it will be correct. Like for example, I'm trying to find the best word to talk about. So basically, for null hypothesis is like the one that I've used an example based on the previous experience or a previous attendance of Ibrahim. We can tell that he will not attend the webinars. So that is a null hypothesis. But now, for the alternate hypothesis, let's say Ian has been attending the webinars twice a week, and then the ALX team decided to do 3 webinars a week. So, based on the previous experience, Ian has been attending the the webinars like a twice consistent, but now they have introduced a new day for webinar. So we are not sure. So when someone like I try to ask you the probability of Ibrahim attending the webinars twice a week, we will do it. He will either attend or he will not attend. So like let's say for example this time let's assume that now hypothesis will come in this context. For example, they have scheduled it that way, and then let's say for example at that day that Ibrahim the day that they have scheduled, Ibrahim is free, and Ibrahim is free. He has data. There's nothing that will hinder him. So when we say that the probability of him attending because he is just free there, now the null hypothesis will say that he will attend because he has the resource, he has the internet, he is free, he will attend. And then, for example, a scenario where he has traveled to Turkana for his project. Now, he has traveled to Turkana, and we know perhaps Turkana there is some internet issues, and we don't know the circumstances. Maybe he is still in the aeroplane, and then the session has started. So we can say that the probability of him attending is zero. So these are just what? These are just assumption, right? These are just assumption, but it could be a situation where Ibrahim went to Turkana with a MiFi router and with a computer fully charged, and then he attends the lesson. Or maybe another scenario, he's in Nairobi still, and then he has everything, internet, but he decides not to attend. He just try to sleep. So you can see that's the when you try to like analyze it that way, then that is an alternate hypothesis. Like you assume the observation are due to some reason. I don't know if I've explained it well, but I think let me use that example so that you can understand very well. Let me just use data because you guys are data people. So let's assume that we have a student, right? We have a student, and um, let's say when we say, for example, I want to use an example of a student. Okay, yeah. Let me say, for example, a student let's say, for example, performs worse than the average. Like, for example, you have the performance of students in a particular class, and then you want to like assess a student. You can say either, for example, a student perform or is worse than average. That's just a null hypothesis. And then when we say, and then and then another now the other one should be, for example, when I use an example of a student, I can say, for example, the student is better than the average that's just an alternate. I don't know if I'm using the correct example, but now, for example, if we also have another one called a one-tailed test. So I'll use again, should I use an example of Ibrahim or student? Because I see student is not bringing up well. Should I use Abraham for you to understand better, or a student?
Yes, use that boy.
Yeah, yeah. Let me use and the boy. Now, if you are testing, if you are strictly testing, if Ibrahim will attend the webinar if he is in Turkana alone. If you are trying to attend, actually to check if he will attend when the circumstances are very, very poor. The attendance, no, it should be not attending. If you are focusing on him not attending, you want to test on him not attending based on those circumstances, only that part where he will not attend. That is called one-tailed test. One-tailed test. It can be either ways. For example, he is in Nairobi, and he has all the opportunities to attend, or all the privilege, all the all the things to attend. So if you are focusing on him, on his attendance, it's called like a one-tail test. And if you are focusing on him only, not attending, that is uh, that is uh, when you just focus on that not attending, is still a one-tail test. And then now the two-tail test, you are testing on both sides. You are testing if he will attend, and if he will not attend. Is it clear, guys? Are you understanding this thing that I'm preaching?
Yes, Nehemiah.
Okay, thank you. So let me try to write here things down so that people will understand better. So let me use an example. Let me talk about the two-tailed. So for example, let me use an example of a mean. So let me say that let's say, for example, mean. Let me call it mean to be something. Let me zoom in. Mean to be something like let's say, assume to be a value like let me give it any value. So for example, and then for example, let's say k. For example, k is something like or any other value to be something like let's say even 10. So when you say when you say, I just use this one as an example. So let me say the mean is equal to is equals to what, to k. Let's say it's equal to k. So basically this is like a for null hypothesis. So but now the other, like for alternate hypothesis, you can say it's not equal. So it means that it can be either greater than or so let's assume that you don't know the value of k. You can say when you are testing, you can say like and by the way, I've used here an example of k, and its probability. We are not sure about the values, but I think you understand it. So for alternate hypothesis, hypothesis, you can say the mean is not equal to is not equal to k. Is not equal to k. It means that you are checking you've so this is like an alternate. It can be when you say it's not equal, there are two options. There are two like probability that can happen here. Who can tell me which and which? When you say something is not equal to k, what can it be?
It can be less or more.
Yeah, it can
It can
be.
be less or more.
Yeah, that is very, very correct. Yeah, thank you so much. So so basically here you are testing like it takes like a two. It is a two-tailed. By the way, let me just use now. When we say a two-tailed, so it means that you can test, for example, if it is it is less than or it is greater than. So if you are testing both, we call them two-tailed test. Two-tailed test. And then there's something, I think I'll show you an example on a t-test, but let me talk about the alpha value. Let me talk about the alpha value. I think I'm trying to rush, but I think we'll create time and talk about it in details. But let me talk about the alpha value just in a few. Now, an alpha value is the level of significance, like how sure are you? For example, for Ibrahim, and he gave me the permission to use him as an example. So his confidence of him attending, I assumed to be 100% because when he was in Nairobi, he has the internet access, he is free, and then uh, he has eaten, and drunk. He is fully in a position to attend the webinar, right? He can't. In fact, he shouldn't be eaten because he will sleep. So he's just hungry, and he has all the opportunities to attend the session. So now that confidence of him, like for example, I assume to be 100%. So that is the in the probability in this hypothesis context is the level of like the how can I say it is how close to the extreme, if it were data, how close to the extreme the data must be for the null hypothesis to be tested. So for example, when you are doing the testing, and then for example you find that the level of confidence is some values. So you can either try to reject those null hypotheses, or accept the null hypothesis. Or maybe, for example, if you are trying to go into these details and understand deeper the reason that can cause Ibrahim not to attend. Perhaps maybe he's not feeling well. He has everything, and then so once you go deep and try to understand some small circumstances, or maybe his children there, disturbing him. So that inconveniences will perhaps try to cause him not to attend. So the confidence will reduce for him to attend the session. Initially it was 100. We assumed that everything is okay. He attends. But now when you go deeper and try to understand the level or the percentage at which he will understand, and then the value that you get, I'm just using an example of a person, but in the data context, when the value that you find, or the data that you get is will determine if that null hypothesis will be rejected or accepted. So, and it usually take it is usually taken between 0.01, 0.05, and 0.1. I don't know if I've explained that well, the alpha value. I use an example of a person. I don't know if you can relate it in the data context. Is it clear?
Yes, Nehemiah.
Yeah, so basically the P, the alpha value, this the level of confidence. How confident are you about your hypothesis? Or maybe you are doing some it is in the data. How confident are you for you to reject or to accept the hypothesis? So for example, if it is 0.01, it is below let's say it is let me use percentage. When it's 100, when it is 100, when it's 100, what do? You will,
minus the significance level.
yes. Yeah, I think that's very very correct. So basically, you can know that it just measures the significance, the level of significance. So and then we also have. I'm going to show you in practical. For me, when I try to talk much, I usually assume that people don't understand. But once I go to coding, I think you'll understand me better. Let me talk about another one, then we shall go to coding. We also have another one called the p-value. So the p-value tells us how close to the extreme the data actually is, how close to the extreme the data actually is. So basically the p-value and the alpha value are compared to establish like the statistical significance. So you like, for example, if p-value is less than or equal to alpha, we reject the null hypothesis. And let's say, let me use an example for Ibrahim and in percentage. So let's say that the significance level, let's assume to be something like what we will reject should be between 50, let's say 50. So we will only reject his hypothesis if we find out that the probability is between not probability, because that one is in values, it is in 0 and 1. Let's say like his confidence of attending, like his confidence on attending the session is, let's say is when I try to go into details and find out that the percentage in probability context that he will attend is a 50 or a below, or a 30 or a 20, anything that is below 50. Then basically we will do what? We will reject that hypothesis. We will reject that hypothesis. Now it means that when you reject the hypothesis, it automatically goes to the other category, which is anyone who can try. I say that we only have two.
Alternate.
Yeah. So when you reject, it automatically goes to alternate. And if it's above, then you can. So essentially in data context, it is usually 0.01 all the way to 0.1. So any value between 0.05, that is what you will do. What you will reject. You will reject you will reject the null hypothesis. When you reject, automatically it goes to the the alternate. Guys, let me just try to code here so that you can understand what I'm talking about. So I'm going to talk about the t-test, though we have many others. Let me use an example for a t-test. So basically the t-tests are used to determine if there is a significant difference between the means of two variables. For example, you have you have two samples. Let's say you have a population. I think I should have begun from the very scratch, but because of time, I think let me just go that way. So let's assume you have a population, but I think someone touched on it. I followed the discussion. Someone touched on these things yesterday, the other day. So population. Let's say we have data. When I say that the population, it means that the data collected or anything, the distribution, or maybe let me just say the data that you have. Let's say you have, let's say you've collected data about 100 people, and then you want to do sampling. So you'll take like samples from the same population, within the same population. You are doing you want to get the difference. You want to basically the t-test, as I said, it's used to define the significance difference between means of two variables. So significance tends between the means or average of two variables, and it will let us know if they belong to the same distribution or not. So it is a two-tailed test because we are testing two samples. So it's a two-tailed test. So it usually has a function called, within that starts the module, the package. We have a function called a t-test underscore ind, and any function or method should always be. So basically this is just a syntax. So let me just add in a comment, because I know I'm rushing, but I think we shall create time in future and then I'll talk about these things in details. So once again, let me import the thing that I don't like typing again. I'm importing the numpy. Did I use here NumPy? Let me just find NumPy. Wow. Let me just type. I don't see if there's harm. So I say import. Hey, boy, import. Import NumPy as an alias np. Also within that SciPy stats, we have a module called the t-test. So from SciPy dot stats and then import t-test. So it means that in this stats module, we also have another module. So this is the package SciPy. We have a sub package, then the module inside that package called t-test. T-test. I think the spelling is correct. Underscore ind. Guys, this is the last one, then I'll finish. And I'm so sorry for taking your time very long, and I had promised. So np dot random dot normal. I'll use a normal. Remember, at the moment I'm just using the random, the number random. I should have imported the. I should have imported what? I should have imported the random module because I'm using. Oh, basically there's no because random is to be. I've just specified within the NumPy we have a function called. We have a package called random, but if you use it direct, you could have just say a random then a dot normal, but because it's a sub package, I've just specified the whole path, path. So let's define a size, for example. Size I'll assign here to, for example, let's use something like 100. Let me generate two of them, and then let me call it. Which variable can I use here? Can I call it testing? Test or a t-test. A test. By the way, guys, in Python we have something that you can't use. One of them is the function, the built-in functions, built-in methods, and the keyword. There are some predefined keywords, something like this import, as, from, and import, and sometimes is parameters. You can see now these parameters, it has like its meaning. So some things like this one you can always try to avoid so that you may not encounter issues. So try to use something that is descriptive. For example, that's why they usually recommend to use those naming conventions. For example, a snake case, so test stats. Yeah, let me just use any here. Then I'll use now that module t-test, because I've imported it as a t-test. So I will not have like to define the whole path scipy.start.t-test because I've just imported that module independent. So let me just pass here, and then so this is v1 version 1. I think I should have used here version 2, and you guys were just following me writing my own things. You wait for me to get the error so that
that we shine.
so that you get the opportunity to shine. All right. So I think let's try this one. Then I think we shall end the session. Guys, there's a lot. This is just the basics. In fact, we haven't even touched the statistical distribution. In fact, we haven't even finished the random, the random distribution. So, guys, you can see, the output. Who can tell us what the p? By there, I talked about the p-value. Who can tell us what the p-value mean here? Hey guys, are you sleeping? How many minutes do I have, Joylene? I have 1 minute.
No,
Well,
just continue.
you added and still.
Just continue. Just continue.
Let me try to wind out. I'll wind up. Yeah. Anybody? I just talked. I think I used.
Jeremiah,
Yes. Yes.
so the p-value is 0.136.
Yes. Yes. And we
So
know
it
that.
means that,
Yes.
yes, go ahead.
No, you are correct. I think I'm the one who was interrupting you. Yeah.
So it means that it's greater than 0.05. So if it's greater than 0.05,
Mm.
we reject the null hypothesis.
Wait.
Is that so?
Can you try to repeat? You can repeat. Sorry, please.
I'm saying
Mm.
the p-value is 0.136.
Mm-hmm.
Okay, which hypothetical test, what were we testing?
We were using like so basically this one the p-value always tests the mean. Always tests the mean. The means of these two. Leads to it is a two-tailed test.
Okay. Okay, but generally, this is what I just I'm thinking. If you're testing a hypothesis, in this case, I think, according to me, like I'm not finding a clear picture of the hypothetical test that we're trying to do. But ideally, you can use the p-value to know whether you can reject the null hypothesis or fail to reject. So from my interpretation, our p-value is 0.1364.
Mm.
You know.
Yeah, I think you've explained well. So I'm the one who didn't specify like that
And
one, but
So,
mm-hmm.
okay, let's say if you're trying to test a hypothesis that the mean of the students who are doing data analytics and the mean for students who are doing data science is equal,
Mm.
then you find a p-value of 0.136.
Mm.
You can be able to say that since 0.136 is greater than 0.05,
Mm.
we will reject the null hypothesis, which says that the mean of the two groups of students is equal.
Mm.
So that means that the mean of the two students is not equal.
Mm.
Yeah, so that's how we are going to use the p-value to test this particular hypothesis. So 0.136 is greater than 0.05. And if the p-value is greater than 0.05,
Mm.
we reject the null hypothesis, which means that the alternative hypothesis is right.
Mm-hmm. Any other person?
I have a question. I thought you actually compare whatever you have gotten, the T statistic, T test result, with whatever that is in the T table
Mm.
at your 0.05 confidence level, and I don't know your table, that table. You compare, then you say if it is the same, the null hypothesis is correct. If it is different, then you fail to
Yeah.
repair. You don't use the confidence levels.
But this is the essence of, okay, my opinion is this is the essence of having this particular software, the Python. Instead of going again to the table and looking at the confidence level, you've already been given the p-value. It's actually calculating the p-value directly. So
Yes.
you can be able to interpret the p-value directly. It's just
against
there.
what? Okay, I'm not
It
reviewing, but
has
this
already done for
value.
you. It has already done for you. You don't need to
no,
do.
Ian.
Yes.
The question
What do you compare it with? That is my question.
0.05.
0. Where are you comparing with the confidence level?
Yeah.
P-value is always compared. Yes. Okay.
I think a p-value of 0.05 is typically considered to be statistically significant, which means the null hypothesis should be rejected. It's just a standard that's there. So if a p-value is less than 0.05, it's considered significant, and you can reject the null hypothesis. So it's not something it's something that's there already defined. So we just it's like a principle, yeah.
Okay, Anthony.
Yes.
Where do we get the 0.05?
Okay. Where we get it is it's statistically it's a set value. It's already there. So if you are it's like the pH values. They're already there. They are set. So if you find that your p-value is less than 0.5, that's how you just know that you need to reject the null hypothesis. It's not something. It's already set.
Okay, I have asked that question because when you collect a sample,
Okay.
there is a confidence level that we just like choose. Most of the people choose 95%, other people choose 90, other people choose 99, and it is very rare for it to go below 80%. So when you just say like you have chosen 95%, that's when you divide that is like 95 over 100, then you get 0.9. So you take 1 minus that 95. That's where you get that value. Then the p-value that you calculate, you compare that p-value with that value that you did 1 minus that 0.95. So it's not that, it doesn't mean that, okay, it's set, but that is something that you as a researcher, you as a statistician chooses to use. Then you compare, from my understanding.
Ibrahim.
Yes.
You see, like ideally, you compare the p-value to the alpha. Alpha is simply 0.05. It's something that is standard.
Okay, Ian, I'm not disputing that. So you want to tell me that alpha is 0.05 globally everywhere? What about those people that use like a confidence interval of 99%? Because my understanding is that that 0.05, you get it after doing some calculation. You come up and say, let us take our confidence level will be 95%. So even if you just go online and maybe key in confidence level of 95%, it will give you all those statistics, like the alpha, the sample size, and all that. If you tell it, give me like a confidence level of 99%, 90%, it will give you that alpha. So me, I will not agree that the p-value is 0.05 standard. Okay, it's there, but it's not the only one.
Yeah, sure, you are right. It's not the only one. It all depends with the level of the confidence level that, let's say you're working in a company and you're trying to create a solution, that will help in just even predicting sales or something. Your company will set up the confidence interval. It's not necessarily 0.05. Whatever you're saying is right. If your confidence level is 92%, 95%, if it's 95% is when you use 0.05.
Yeah, and that is something that Mimo was saying now. You see, maybe if you've chosen that 95%, then that alpha that you get is the one that you are comparing with the p-value. And that is what Mimo was trying to ask and try to explain. Because we need to compare it to something for us to either reject the HO, which is the null hypothesis, or accept it.
Okay,
From my
the
understanding.
question I got from Nemo was like he was trying to ask if the p-value that you've gotten here, 0.136, you again have to look at it in the t-test tables. I don't know whether
Oh,
that is what I thought. That's why I said the p-value, you don't need to go again to the t-test tables to look for, because the system has already calculated for you. It has written for you here, p-value is equals to 0.136. So you don't need to go again to check. That's what I was saying. But whatever you're saying is totally right.
Yeah, I think that is maybe where you did not get Nemo correctly, because Nemo was like, what are we comparing to? This p-value, what are we comparing to it? And that, from my understanding, is that we compare it to the alpha. That's for it to now enable us to make that decision. Right? Sorry guys for,
Yes,
for
that is totally
arguing.
right.
Sorry guys for arguing. And I had another final one because I had anybody else said
Okay, I've
something or
understood,
I
but
thought.
okay, I've understood. Maybe I'll just continue just conceiving so that I can try to understand why we are comparing with the alpha. Because me, I always thought that.
Nemo, but either way, hii p-value iko hapa 0.136. It's such a big number. Like kwa p-values, depending on your field of study, kama like in high school, they normally gave us in the question. So you will just compare with the p-value they've given you in the question. It can be 0.05, it can be 0.01, it can be 0.001. So in any case, 0.136 is such a big number.
Okay, so Nemo, you see, like the example that Nehemiah and Ian have used, whereby we are saying that the mean of the marks or the mean of the scores for data science students is exactly the same for data analytics students. Then after collecting the sample, we come up with a confidence level. Then we say our confidence level is 95%. So we shall like divide that 95 by 100. Then we say 1 minus 0.09 so that we get that 0. I think it's 5. Sorry, I can't like do that. So that is our alpha now, that 0 point something. Then from that sample, we will now calculate the p-value with because doing them manually, Python can give us the p-value the way it has given us. Now we will compare that p-value, the one that we have calculated using Python, using the mean from that sample and other figures from the sample, then compare to that alpha, that our 0 point something, for us to make a decision. So there are some calculations that are being involved. And one of the things maybe in Nehemiah I had you say, you're saying that we are doing a two-test. For me, from my understanding, that when you're doing a two-tailed test, that 0.5, then we need to divide it by 2. Because we are not doing like a one-tailed test. I don't know if
Can I
you
just
will agree
summarize
with me
this?
on the same, because I'm a bit confused there.
Okay, let
But
me
that's what I understand.
hello, are you able to hear me?
Yeah, you can
I
hear
think
me now. Go ahead.
let me try to summarize this one, and then I think we shall end, because the reason here I should have brought it from the very basics so that you understand it better, but I was in a hurry. I couldn't like brought it very well. But in a nutshell, within this t test, when you are doing the t test, it has already the predefined the p-value. Like for example, the scenario where I was using Ibrahim as an example, I had set like to be 50%. I was using the percent. Like when I tried to find out the factors that could make Ian not to attend the session, when for example the children are disturbing, maybe he's not feeling well, or maybe some other things. When I try to calculate, how do you calculate those things? But for example, when you do some calculation, then you find out that it's less than is less than the value that you've set there, like a p-value that you had set, for example, to be 50, then this is where you define that, like the you are going to use now that p-value. But now in the context of this one, it's already defined to be 0.05. So anything larger than, anything greater than that, you will accept. So in a nutshell, the p-value, as I said earlier, is the probability of observing a test statistics as extreme as
Nehemiah,
yes,
we don't accept.
yes. That
No,
example.
no, Nehemiah is correct. Nehemiah is correct. You fail to reject, actually. Yeah. We
Yeah,
don't
but you
accept.
didn't say accept. You just
We
say
fail
fail
to
to reject or
reject. I
But
think he meant in a positive way, basically, I think. Yeah. That
See,
you fail to reject.
I thought we are rejecting the null hypothesis because the p-value is larger.
yeah,
If it is larger, you don't reject. You fail to reject. Yeah. The
Well,
smaller the p-value, the smaller the p-value, the more stronger case it actually shows
I,
for the
yes.
null hypothesis.
Yes, Abdikadir is right.
Let's try to put it in this way. So let's say we have like one. Let me use again the person Ibrahim. So we want to see like we are testing if we should accept the hypothesis. Hypothesis is like an assumption about if someone will, for example, Ibrahim will attend the webinars. So for example, if it's above 50, so the score goes above 50. So what does it tell about the hypothesis, that null hypothesis about that you're using? So it means you have to accept it because it's above like the p-value. So you are accepting. Do you
you
understand
don't
the logic?
accept. Nehemiah,
Hmm.
if you say accept, people are going to say accept. Actually, accepting should not be
Oh,
used.
oh,
When
it is
you
opposite.
either you either reject or fail to reject,
Yes. Oh, I
but
think.
accept should not be used.
Hmm, hmm. So like for example, uh, for example, yeah, by there I think I've interchanged. I've used it in. Let me try another example. So let's say we remember that the null hypothesis is the null hypothesis should always be discarded. Like for example, the null hypothesis. These are like these assumptions not based on like you don't like consider the factors that the internal factors that will can hinder his attendance to the sessions. So by default, the null hypothesis, it means that it shouldn't be what the null hypothesis, it means that it shouldn't be used, right? The null hypothesis because you are not considering other factors. So when you are rejecting, when you are accepting, it means that you are rejecting that that, that hypothesis. So it will go to the alternate. I haven't put it well, guys, and I think we need to schedule another session. Then now we shall talk about it in a proper way, I think, because the discussion will go on and Jaylin will end the meeting. But just understand, but by default, the null hypothesis is automatically like shouldn't be considered. It shouldn't, like it's already negative. So when you accept, it means that it is in the alternate.
When you fail to reject.
Yeah, yeah.
Yeah,
Yeah,
just
you fail. But I think that's the correct word that I should
yeah.
have used and ended the discussion. Yeah.
You guys should also understand that Nehemiah's background is in terms of technology and not statistics. So for a few of us who have gone through statistics, that's why you're shining. Fail to reject, reject. So just understand.
Yeah.
No, Nehemiah is doing a good job, bro.
Yes.
Congratulations, man.
So guys, I
Now,
think we have a
Nehemiah,
lot.
maybe just a simple example. Without wasting your time, guys.
Not your
Eh,
time. Actually, we have a timekeeper here. We are trying like to be strict,
okay.
to be actually genuine to ourselves, or how can I say, to be yeah, to be genuine to what we put. Yeah, you can.
That's good.
You can continue.
Yes. Now I just want to use an example. Let's say of let's say an animal, something like a dog. Now I want to say that I call upon two people. Let's say our p value, our confidence level is 95%. So having a confidence level of 95% means that our alpha is going to be 0.05. Now that is what we'll use to compare with the p-value. Let's say in our case, our p-value is 0.135. And we are saying that if the animal that we are seeing is a dog, then that is our hypothesis. We are testing if we are literally saying that this animal is a dog. And there's someone else who is saying that this animal is a cow, but the animal is a dog. So now we need to do some few statistics. We need to look at this dog in details. You look at the basic structure of a dog. Now in this case, I mean, just picture it in a statistical aspect. Now you're saying that if you find your p-value, since our confidence, okay, I can use me and Nehemiah. Nehemiah thinks that that particular animal is a dog, and Mimi, I think that particular animal is a cow. But we are going with Nehemiah's hypothesis, that is a dog. And I want to kind of disqualify his hypothesis. So we'll go and do a particular test for this particular animal, by studying its anatomy and all that. But now in this case, in a statistical aspect, think about the numbers that you're going to take or whatever variables that you use. Now, after we've done our test, we need to find, Nehemiah has a confidence level of 95%. So that gives us an alpha score of 0.05. After we've done all our statistical analysis, in this case, if you're using a dog, we've analyzed its anatomy and all that. Our p-value is 0.136. And Nehemiah is very confident, he has an alpha value of 0.05. Now, after we've done our p-value, and we found that, our p-value is 0.136, we'll compare it with the alpha that we had of 0.05, to identify, is it a dog or is it a cow? So if our p-value is less than or equal to 0.05, we will reject Nehemiah's hypothesis. Nehemiah's hypothesis says that that is a dog. And if the p-value, is greater than 0.05, we will fail to reject Nehemiah's hypothesis. Now, in this case, we've done all the statistical anatomy, and we found that this particular animal actually has the structures of a dog. Now, look at it in a statistical aspect. We are comparing the means between two particular groups. You've done the means, and you find that whatever the initial hypothesis was, it was that the two means are equal. For the dog side, we find that this animal has the anatomical structure of a dog. That's why it gives us a p-value of 0.136. Since the p-value is 0.136, and then the confidence level that we had agreed with Nehemiah was 95%, and 95%, being giving us an alpha value of 0.05, and now we are comparing our 0.05 with the p-value of 0.136. This basically will tell us that Nehemiah was actually confident that this is a dog. And from our statistical analysis, we were able to get a p-value of 0.136, which is greater than 0.05, the alpha level the alpha that we had agreed with Nehemiah, 0.05. I don't know whether I'm clear or I've confused someone, but that's what I can just say.
You're doing well. So what now happens when you have your result greater than 0.05? Do you reject or do you fail to reject?
You fail to reject.
Yes.
The p-value should be small enough for you to reject the hypothesis. So if it were 0.01, you reject the hypothesis. If it is more than the alpha value, you fail to reject the hypothesis.
But here is 0.136 that you got, not 0.01.
Yeah, that's why we fail to reject.
In short,
So the
all I can
dog
say
is the
is,
cow.
in short, all I can say is that the higher, in this case, the higher the
It is
p-value.
still not yet a cow.
Yeah, if it were 0.03, it would have been a cow. Since 0.03 is less than 0.05. In short, what I can say is takeaway message is this: the greater the p-value, the more confident I am. If p-value is greater than 0.05, it means that the null hypothesis is right.
Is right. Oh.
Yeah,
Okay, I've understood.
Nemo,
That
here we are
thank you so
confident.
much.
We are confident that this is a dog.
Oh, so
Yes.
if the p-value is higher than the alpha, you are essentially like saying the null hypothesis is correct.
Yes, yani
The dog
Yes, that's why you fail to reject it.
Yeah.
I have understood finally.
Yeah, I think let's just end it here. When we proceed, I think I will complicate everything here. But guys, this is just an entry level. In statistics, it's so profound. In fact, we didn't even touch or finish the normal the random distribution. Apart from that, we have the statistical distribution. We need also to understand the formulas there, and then many other things that we need to discuss. So this is just an entry level, because I always think like, for example, if we begin at that peak, many who are beginners will not understand the basic concepts. But I think from this point we can advance and talk about those complicated, including using different functions and stuff like that. But because of time, for me, I always have issues with time. I never finish
Yeah,
things.
Nehemiah, I gave you 30 minutes from 10:37. You went ahead and took an hour.
Actually, you see, it's just my problem. So, guys,
But
I
the
think,
dog alone took another 10 minutes.
and yeah. So, guys, I think we'll need to schedule. I think we didn't even finish NumPy. We didn't even finish what was it? Matplotlib, many other things. So I think in future, if we will ever have time, we shall talk about these things, because I think they are very important in data science. So guys, I think for me on my end, I'll end it here. I'll just end it here.
Okay, thank you and good night, guys.
Yeah, thank you so much.
Good night.